Next example. A phone is rumored to last less than its advertised 14-hour battery life under heavy use. A sample of 40 phones has a mean battery life of 12.8 hours with a standard deviation of 3.1 hours. We're going to test this claim at the alpha of 0.01 at a 1% alpha level of significance. So let's build the test and test it. Let's figure out what is our null hypothesis, what is our alternate, and what type of test is this. So a phone is rumored to last less than its advertised 14-hour battery life. So the company is claiming that the average is 14. We are going to test, is that actually a lie? And the phones are going to last less than 14 hours. So whenever we use less than and we want to know if the actual mean is smaller than a certain number, we now have a left tail test. What we think is true from the company's advertisement is that it should be 14. We actually believe the phone is going to last less than 14. So it's a left tail test. So let's go get our test statistic, which will be a t statistic. In order to get our t statistic, we're going to take the sample mean. So I'm going to go find my sample and find there's the sample mean of 12.8 minus the null hypothesis, what we think is true of the whole population, divided by the sample standard deviation over the square root of the sample size of 40. So 12.8 minus 14 divided by 3.1 divided by the square root of 40. I will get a t statistic, a test statistic, a t-score of negative 2.4482. Now I need to go, we already identified this as a left tail test, so I need to go find the left tail. And since it's a left tail test, when I find the left tail, I automatically have my p-value. So let me jot this down so I don't forget it, negative 2.4482. Oh, and I also need the sample size when I go over here. So my sample size was what, 40? Okay. So I'm going to change my t-score and my spreadsheet here. Negative 2, oh, that's not the negative. Negative 2.4482. And now it didn't automatically, so over here, I need to, I'm going to scroll over and I need to change the t statistic that I put into the formula. Actually, I'm just going to, okay, so you're going to type in equals t dot dist. I'm going to type in my t statistic, my t-score, comma, the degrees of freedom, which is your sample size minus 1. I had a sample of 40, minus 1 is 39, comma, true. Always true. And I already had this program to do 1 minus the left tail, but that didn't even matter for this problem. Okay, oops. Oh no, undo, okay, good. This was a left tail test problem, so I'm just gonna jot down that left tail, 0.009. And since this is a left tail test, the second that I have my left tail, I automatically have my p-value for the problem. So now we can decide, is the p-value larger or smaller than the alpha, our level of significance that we're testing? I see here that my p-value is in fact a little bit, no, wait. My p-value is actually, oh, I see what I did wrong, why I was confused. My level of significance is 0.01. So my p-value of 0.009 is smaller than my alpha, our level of significance, which means we have statistically significant enough evidence to reject the null hypothesis in favor of the alternate hypothesis. So we have statistically significant enough evidence to reject the company's advertisement that the phones last 14 hours. And in fact, we will now believe the phones do last less than 14 hours based on this sample.